Okay. Hi, 3A7. This is a recording. This for this recording, you will need your 3B textbook with you. Please turn to page number 25. Alright, page number 25. Basically, in this short example, I am going to demonstrate to you why is it that sometimes you can get two different answers when you calculate angles using the sine rule. Alright? Okay, so here I'm drawing the triangle, and you will notice that after I have drawn the triangle, they only give us three pieces of information. Alright, and the three pieces of information is that this angle here is 35, this angle here is 20, and this angle here is 13. Alright, and then they ask us to actually calculate what is the length of ACB. Okay, so ACB. Alright, so it is this angle right over here, okay, which I'm going to mark in red, okay, because this will become important to us later on. Alright, so here's how it's set up, and then now let's straight away apply the sine rule. This, of course, this unknown angle, let's call it theta. Okay, so we'll start off. I'm going to use blue color for the working. Sine theta, okay, equals to, sine theta over 20 equals to sine 13 over 30. What am I doing? Sine theta equals to sine 35. Alright, sine 35 over 13. Okay, so now we've set it up and you have your calculator. You can press the value of theta. You can find the value of sine theta. Okay, so sine theta equals to, okay, I'm going to give you a number. In order to calculate this number, here's what you do. Okay, it's 20 times sine 30 over 13. Okay, so I'm going to use my Google calculator. 20 times sine 35 over 13, sorry. 20 times sine 35 over 13. Okay, so 20 times sine 35, okay, divide by 13. Okay, and so we get this figure 0.88242 243, 0.88243, 0.88243. Okay, and of course here is where it gets icky, because there will be two answers for theta now. Your calculator will only give you the smaller one. Okay, so go ahead and press arcsine 0.88243. In fact, I'll do it on my Google calculator to show you. Arcsine 0.8243, and then we'll actually get 61.936. Okay, but of course, remember, when we get the final answer, we should always round it off to 3 decimal places. So here you have a 6. Whenever you get a final answer for angles, you round it off to 1 decimal place. Okay, anything that's not an angle is 3 significant figures. Alright, so if we have this angle at 61.96, this is the first case. Okay, so now actually I'm going to use a different color so it's easier for you to see. Alright, okay, so erase everything here. Okay, so everything's fine, and the first case scenario is that this line, okay, I'm going to use a red color. This line here is 13 as the question requires. Okay, and our angle here is 61.9. Okay, but okay, now I need you to notice something. Okay, angle here 61.9, this is 13. I need you to notice that actually, you see this length 13, right? There actually could very well be, this is 13 now. Actually, without changing the size of this length, 13 could be in this position as well. BC could be right over here. Alright, so the thing is that this is only one answer. This is another possible answer. Okay, and let's see how this works out. Okay, I'll just leave this green thing here. Alright, so now here's where we calculate the OR. Alright, so okay, theta is 61.93 or Okay, so now we take our calculator. 180 minus 61.936. Okay, so it's 118.064, and of course we're going off the 118.064. Okay, and of course rounded it off, it's 118.1. Okay, 118.1. So this second angle, where exactly does it manifest? Okay, so you see my green line point here. So remember, this red line and red angle, okay, is only one of the solutions. The second solution could be, let's say, here as well, with this green line also being of length 13. Okay, but this green angle over here, this green angle, it's the 118.1. Okay, so I hopefully this will help you explain that why sometimes there's two answers, because if you are only given three pieces of information like what we've shown, then there are two possible triangles to be formed. Okay, so I hope this helps you understand this. By the way, the official name for this is called the ambiguous case of sine rules, so you always have to be a lookout for it. So in this case there's two answers, but remember, there will come a time where you actually have to reject one of your answers, like I showed you yesterday. Okay, yesterday being the Wednesday of week 3 of term 3. Okay, so I'm going to stop the recording here, then I'll move on to another question.